This video, we're gonna go over some basic equations under Ohm's law, electric current and power. Okay, electric current. Let's say we have a circuit. It's our resistance. It's our negative terminal. Here's our negative terminal. Positive terminal. Let's say here's our resistance. So the current passes from positive terminal to negative terminal. This is our current. But you know that our current formula says that the current is equals to rate of charge, the rate of charge over time. The charge is measured in coulombs and time is measured in seconds, delta t, and therefore the current is equals to coulomb per second, which is equals to ampere, but you can just call it as amps. So the negative terminal, from the negative to what? From negative to positive. Therefore we have what? Negative is electrons, the electron is negative, or positive is current. Okay, let's say we have the electric. Okay, so we have electron, which is negative charge. We have the value of electron, which is 1.6 times 10 exponential of negative 19 coulombs. But we have a negative sign because it's electron. Okay, let's say our electron is equals to negative 1.6 times 10 exponential of negative 19 coulombs. So that's for that for electric current. Our electric current is equal to change in Q, which is measured in coulombs, divided by change in time. Okay, that's our current, and this is our value for electron. Maybe we can use them for solving some problems. Okay, let's get back to Ohm's law. Ohm's law. Ohm's law, which is V is equals to IR. Ohm's law is three electrical properties, which is volts, current, and resistance. The voltage, which is the potential difference, we can call it as voltage, which is measured in volts, and our current, which is I, can be measured in ampere, which is amp. Okay, and our resistance, which is the ohm, which is measured in the SI unit of resistance is ohm, which is ohms. So therefore, let's say that we have, when our current I is increasing, and also the voltage will be increasing. But when our resistance is increasing, the current will decrease. This means that the current and voltage are directly proportional. But what? The resistance and the current, they are inversely proportional. That's the reason why if the resistance increase, so the current will decrease. But when the current increase, the voltage will also increase. Okay? Let's move to electric power. When we say power, power is the rate of voltage times the current. From the word power, what did we mean? Power is the rate at which energy is used or produced. So don't forget with the Ohm's law equation, V is equals to IR. So therefore we can insert the value of V inside this formula. Okay, let's see. V, okay, the power is equal to V is equals to IR in this form. So therefore we can insert the value of V through this. Let's say that our V is IR, I times R times our I, which will give us P is equal to, we have 2I, so we can just say I square times what? Times R. Okay, let's insert the value of I. We know that current P is equal to our V times, what is our current? If we are to find current, we have our formula of I is equals to V, let's say what? I is equals to V over R. That's our current. So let's say that V divided by R we just insert the value of I to do this. Let's say that our power is equal to V times V is V squared divided by R. So keep that in your mind of these three equations. V is equal to V squared over R. The equations are most important to you for calculations and problems. In this equation, and the next equation, which is P is equals to I squared times R. Here are some problems that we will solve in order to understand Ohm's law, electric current, and power. Okay, let's move to number one. Number one says a current of 3.8 amp flows in a wire for 12 minutes. How much, i.e., how much charge passes through any point in this circuit during this time? Okay, let's move to 5 here. Our current, we have been given current. Our current I is equal to 3.8 amp in a wire for 12 minutes. That is time. Our time, which is T, is equal to 12 minutes. Yes? Okay? How much charge? If we can remember, we have the charge, the electric charge formula, which is I is equals to change in Q divided by change in time, which is our current is equal to change in Q divided by change in time. But the question said to find what? We are to find the charge. We are not to find the current. So you can just cross multiply I, the current times time, which is equal to the current times time is equal to charge. So we can just say the current is equal to I times T. Okay, before we proceed, we have to convert minute to second. We can say 12 minutes times 60 seconds make 1 minute, 60 minutes make 1 hour. So we can just say the minutes, 60 seconds make 1 minute. So we can just multiply by 60 seconds divided by 1 minute. Okay, the minute will cancel minutes. We are left with 12 times 60 seconds, which is equal to, so we give us 720, but let us try 12 times 60, 720 seconds. Okay, we are having our time, which is 720 seconds. Okay, let's say our charge is equals to our current, which is 3.8 amps times the time, which is 720 seconds. 720, therefore current is equal to 3.8 times 720. 3.8 times 720, 2736. So therefore the charge is 2736 what? Coulombs, because charge is measured in coulombs. Okay, let's move to pi b. Pi b. How many electrons will this represent? If we look at our first questions, our answer is in coulombs, which is 2736 coulombs. So what? The question is electron. So we are what? Put the charge of electrons negative, and we should divide it by what? If we recall, our electron is negative 1.6 times 10 exponential of negative 19 coulombs. So negative 1.6 times 10 exponential of negative 19 coulombs. Here we have 1. So therefore coulombs will cancel coulombs. Therefore 2736 times negative electron divided by negative 1.6 times 10 exponential of negative 19, so that we can calculate. Okay, 2736 divided by negative 1.6 times 10 exponential of negative 19. Okay, That's our final answer. 1.71 times 10 exponential of 22 electrons. So that's for 5B. Okay, this is the next question. Before we talk about the question on the electric currents, but here we are just talking about voltage and what and resistance. Okay, let's start. Number 2. A 10 voltage battery is connected across a 250 ohms resistor. Okay, let's say we have a battery, a resistor. Resistor is our negative terminal, positive. We have 10 voltage. Our resistance 250 ohms. Okay, how much current passes through the resistance? Okay, we have to recall our Ohm's law. V is equals to IR. So in here we are to find what? We are to find the current. So we can say V is equals to IR. We should divide both sides by the resistance. Resistance comes to resistance. Therefore, the current is equal to voltage divided by resistance. Therefore, the current, this is our voltage, 10 voltage divided by our ohms, 250 ohms, which is our resistance, which is equal to 10 divided by 250 ohms, which is equal to 0.04. So therefore, the current is 0.04 amps. So this shows that the current that passes through the resistance is 0.04 amps. So therefore, our current that is flowing through this resistance is 0.04 amps. Okay, that's for 5. Okay, let's move to 5B. 5B says that how much power is dissipated by the resistor. Okay, we can recall our formula. Okay, the formula for power dissipated by a resistance. We can use this power. We can use it. P is equals to, the power is equals to the current square times R. So let's say that the power is equal to I squared times R. Okay, power is equal to, is our current, 0.04 square amp times our resistance. We have 250 ohm. Okay, power is equals to, when we say 0.04 square, 1.6 times 250 ohm, which is equal to 0.4. So therefore, that's our power, which is what? Watts.